हेलो माय डियर मैकेनिकल चैंपियंस, कैसे हैं सब लोग? व्हाट्सअप अपने केमेना चेन यल्लवनारू myself Chandrasekhar welcoming you all to this beautiful wonderful session of thermal engineering basic thermodynamics, that is second law. So please guys do join me fast, and those who are already here, please do respond me through the comment section if my audio and visual quality are fine or not, so that we can start the session at early as possible, as early as possible. All right. So in the previous session, we discussed about the first law of thermodynamics, that is also known as Joule's law, energy conservation law, or we can also call it as quantitative law, because the first law of thermodynamics talks about the quantity of energy which is conserved. But what about the second law? The second law of thermodynamics talks about the quality of energy. So energy is having quantity, that is the magnitude, as well as the quality, that is the grade of energy. So the second law of thermodynamics, which is also known as the directional law, which is also called as qualitative law, talks about the quality of energy, right? So we are going to discuss everything about the second law of thermodynamics in today's session. Yes. Hi Ali, welcome, good evening, namaskar, adab, shubh chandya, good evening, sat sri akal, assalamu alaikum, vanakkam. Please settle down fast, sit back, relax, and enjoy the beauty of second law of thermodynamics. All right. Am I audible and visible to all of you properly? Shall we start? For those who are in the session for the very first time, or those who are meeting me for the first time, this is my quick, simple, short introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSU, and I am a mechanical engineering graduate from IIT Delhi, also cleared engineering services examination, and I had also worked in Steel Authority of India Limited for a couple of years. So my total industry experience is more than 4 years, and teaching experience we talk about is more than 10 years. And I am quite comfortable in the mentioned subjects of mechanical engineering. If you have anything to discuss in any of the mentioned subjects, you can always connect with me through the mail ID, which is mentioned on the top. And you can join me on the Telegram as well. Hi Nanu, good evening, welcome. How are you all? I hope everyone is safe and sound and doing your preparation with the full dedication, hard work, enthusiasm and motivation. So do not forget to like this session, please guys. It is my humble request. Do like, share and subscribe our BYJU'S YouTube channel, so that session reaches to all the individuals who are preparing for GATE 2024 examination. And if you have not joined me on the Telegram yet, do join me on the Telegram, that is Mechanical by Chandrasekhar, and the link is also mentioned. Hi Gokul, welcome, good evening, how are you? So if you have not attended my previous session on first law of thermodynamics, where I have discussed about the first law for a thermodynamic cycle, how to apply the first law of thermodynamics for a thermodynamic cycle. I have discussed about the first law of thermodynamics applied to a process and non-flow process, and the first law of thermodynamics applied to the flow process also, which can be steady state process or it can be unsteady state flow process. So everything about the first law we have already covered in the previous session of this startup series. So please go through that session also if you have not attended it live, and do not forget to attempt this scholarship test, which is going to happen on 4th of June. I'm all good, Gokul. Welcome to the session. Please sit back, relax and enjoy the beauty. And do not forget to share your knowledge, share your understanding about the second law. When I say second law of thermodynamics, what comes to your mind? Please tell me, what do you know about the second law of thermodynamics? So you can register for this scholarship test. The link to register for the scholarship test is already mentioned in the description box. So you must have heard so many times, so many noise that conserve the energy, energy conservation. There are so many discussion panels. There are so many events where people talk about the conservation of energy. But do you understand that the energy is always conserved? Isn't it? Energy can neither be created nor be destroyed, which we have been studying from our school days, which we understand from our childhood, that energy can neither be created nor be destroyed. So there is always an energy conservation. Then why there is so much noise of conserving the energy? Isn't it? Doesn't it look contradictory? Tomorrow will be the question practice. No one. The question practice will happen tomorrow at 11 a.m. for the basic thermodynamics. Do join me tomorrow at 11 a.m. for practicing the wonderful question on first law, second law, as well as the basic thermodynamics. All right? Yes. Now, whenever people talk about the energy conservation, they always talk about the conservation of quality of the energy, because the quality of energy is degrading continuously. All the processes are happening to decrease the quality of the energy. So what is the need of R is, quantity wise the energy is always conserved, but quality wise there is always a degradation of energy. So the need of the R is to preserve the quality of the energy, not about the quantity of energy. And that is what is second law is all about, right? Law of degradation of energy. Second law of thermodynamics. Shall we start? Is also known as qualitative law. Why do we call it as qualitative law? As I said, energy is having quantity as well as quality. Quantity as well as quality. So we always want the energy to have higher quality, which can be easily converted into useful form. The energy which is of higher quality means it can be easily and completely converted into useful form. And the energy which is of lower quality cannot be utilized for useful purpose. It cannot be fully utilized for our use. So that is why the energy, the quality of energy should always be conserved, and that is all about the second law. So for an example, work is a form of energy transfer. So work is known as high quality energy. Work is called as energy of higher quality. Why? Because the work can be easily and completely converted into useful form. Whereas the heat is treated as energy of low quality. Heat is considered as the energy of the low quality. Now you can search startup series, the series name is startup series, and you can search on YouTube first law of thermodynamics. Or if you are part of my Telegram group, are you part of my Telegram group, Nanu? If you are not part of my Telegram group, do join me on the Telegram. I have already shared the link of first law of thermodynamics on my Telegram group. That is Mechanical by Chandrasekhar, right? You can find the link and you can find the session on YouTube through that. Clear? So there is a complete conversion of higher quality of energy into low quality of energy. But the reverse is not correct. The reverse is not true. The complete and conversion of low quality of energy cannot happen to the higher quality of energy. Higher quality can also be called as high grade energy. The work is high grade energy, heat is called as low grade energy, right? Higher grade energy and low grade energy. Similarly, an energy at higher temperature is always of higher quality. The same energy at lower temperature is of lower quality. For an example, if we are talking about heat, heat is definitely having the lower quality than the work. But heat at a higher temperature, the same amount of heat at higher temperature is of higher quality compared to the same heat at lower temperature. The same amount of energy at lower temperature is of lower quality. The same amount of heat at higher temperature is of higher quality. So it also depends on the temperature, at what temperature a particular energy is utilized. That improves the quality. Higher temperature always improves the quality of the energy, right? So that is why the second law of thermodynamics is called as qualitative law. And the second law of thermodynamics is having one more name, that is called as directional law. It is called as directional law. Why do we call the second law of thermodynamics as directional law? Anybody? Why it is called as directional law? Because the second law of thermodynamics gives the direction to a particular process, and through the concept of entropy, it gives the direction to a particular process. Gives direction to a particular process. That is why it is called as directional law, and through the concept of entropy. What is entropy? As the entropy increases, if the entropy is high, we can say quality of energy decreases. So we can say, according to second law of thermodynamics, a natural process always takes place in the direction of decreasing quality of energy. In the direction of decreasing quality. A natural process always takes place in the direction of decreasing energy quality of energy. For an example, do you know heat always flow from high temperature to low temperature? Heat always flow from high temperature to low temperature naturally, isn't it? Why heat always flow from high temperature to low temperature? Because the heat at higher temperature is having higher quality, whereas the heat at lower temperature is having the lower quality. So the process always takes place in the direction of decreasing the quality of energy. Do you guys understand it? So a process is happening, or we can say, in other words, if you talk about the entropy, you must be familiar. I am not talking about the entropy in today's session, but yes, according to second law, we can say a process can happen only when it increases the entropy of the universe. Only those processes are possible for which entropy of the universe increases. A process can never happen which decreases the entropy of the universe, or we can say a process can never happen which increases the quality of energy. So that is why we need to preserve the high quality energy to utilize it further purpose. So the final conclusion involving the first law, that is the quantitative law, and the second law, that is the qualitative law, we can say a process must satisfy both the first law, that is the quantitative law, as well as the second law, that is the qualitative law of thermodynamics to proceed to happen. That is how we can find out the direction of a particular process. I hope this is clear to everyone. Is this all fine? If anybody is having anything to ask, you are most welcome. Otherwise, allow me to proceed further in our discussion. Do you guys know the second law of thermodynamics is made up of two statements? What are those two statements which constitutes the second law of thermodynamics? What are those two statements which are taken together to frame the second law of thermodynamics? Anybody? To understand the second law of thermodynamics, we need to understand the thermal energy reservoir. What is the thermal energy reservoir? Yes, no one. One is Kelvin-Planck statement. What is the other one? Anyone can let me know what is the other statement to make the second law complete? Second law of thermodynamics is made up of two statements. So before proceeding further, let us understand the thermal energy reservoir. What is a thermal reservoir? The thermal energy reservoir is a hypothetical body which is having large heat capacity, infinitely large heat capacity, such that even if we remove the heat from this body, there is no change in its temperature, or we add any heat to this body, there should not be any change in temperature. So the thermal energy reservoir is having no change in its temperature. Either we remove some heat or we add some heat to it. All right. Yes. Vijay. Good. So the Kelvin-Planck statement and the Clausius statement. So the thermal energy reservoir can be further divided into two parts. It can be a source. What is a source? Source means which gives the heat. The source is the reservoir which supply the heat to the system. We supply heat to our system. That is known as source. For an example, sun is a well-known example for a source. Sun is the source of heat energy. We get the heat energy, we get the thermal energy from the sun. Or we can call it as, we can say, furnace, blast furnace can be the source of energy, thermal energy. Or it can be the nuclear reactor. These are supplying the heat to our system and there is negligible change in their temperature. That is why they are known as source. The thermal energy reservoir is known as source. Similarly, the sink. What is the sink? The reservoir that receives the heat from the system. The reservoir which receives the heat from the system is called as sink, which does not experience, which does not observe any change in its temperature. For an example, atmosphere. Environment is an example of sink. All the heat is released to the environment. Or ocean. When we put some thermal energy to the ocean, because ocean is very large, there is negligible change in its temperature. Or river, environment, etc. These are the example of sink. Now let us define the second law of thermodynamics through the two statements. One of them is called as Kelvin-Planck statement. Are you guys familiar with the Kelvin-Planck statement? In simple words, I can say, according to Kelvin-Planck statement, the complete conversion of low grade energy into high grade energy is impossible. Complete conversion of low grade energy. We can call the low grade energy as heat. Heat cannot be completely converted into work. That is the basis of Kelvin-Planck statement. That is what is Kelvin-Planck statement. The complete conversion of low grade energy into high grade energy is impossible. Low quality energy into high quality energy is impossible. Whereas the complete conversion of high quality energy into low quality energy is definitely possible. High to low is possible, but low to high is not possible. So exact statement, if we talk about, is it is impossible to construct a device operating in a thermodynamic cycle. It is impossible to develop a cyclic device which produces work, which is called as high grade energy, while exchanging heat, that is low grade energy, with a single reservoir only. What does that mean? If there is a cyclic device and the system is getting heat from a source and all the heat is getting converted into work, this type of cyclic device is impossible. If we talk about the first law of thermodynamics, as per the first law of thermodynamics, Q is equal to W. First law is not getting violated. First law is applicable. That is, the energy in is equal to energy out for a cycle. For a thermodynamic cycle, E in is equal to E out. So we can say Q is equal to W. That does not violate the first law of thermodynamics. But second law says that the work output cannot be equal to heat supplied. According to second law, the complete conversion of low grade energy into high grade energy is impossible. So the work should always be less than Q. The work output, which is high grade energy, is always less than the low grade energy, that is Q. So this is called as PMM2. This is called as perpetual motion of machine of second type. Continuous motion machine of second type is impossible. It is impossible to develop a perpetual motion machine of second type. PMM2 is impossible because it violates the second law of thermodynamics. Why it is impossible? Because it violates the second law, or the Kelvin-Planck statement of second law, that the low grade energy cannot be completely converted into high grade energy. I hope this is clear to all of you. And based on the Kelvin-Planck statement, a cyclic device is invented based on the principle of Kelvin-Planck. That cyclic device is called a heat engine, work producing cyclic device. So that is called a heat engine, which is based on Kelvin-Planck statement. Do you understand? The heat engine is a work producing cyclic device and the cycle is clockwise. Clockwise cycle always produces work, anti-clockwise cycles always consumes the work. So in designing the heat engine, there are three things required. One is the working fluid, or we can call it a system, which is undergoing a thermodynamic cycle. Working fluid undergoing thermodynamic cycle. The second one is the source which supplies the heat, and the third one is sink. Single source will not be able to, cannot make a heat engine, because there is a complete conversion of low grade energy into high grade energy is impossible. Only part of low grade energy will be converted into high grade energy, that is the work. The remaining portion of the low grade energy or the heat must be thrown to the sink. So the third should be a sink. So this is how the heat engine is developed. The high temperature reservoir at TH, can we call it a source? Because it is supplying energy to the working fluid. It is supplying QH, that is the heat supplied. QH is the heat supplied from the source to the working fluid or our system. This is the system. And due to which cyclic device, there is a net work output, there is a work produced by the cyclic device or by this working fluid undergoing a thermodynamic cycle. There is some remaining heat which is thrown to the low temperature reservoir, which is at TL, that is sink. QL is the heat rejected to the sink from the system. Q is the heat rejected to the sink. Hi Ishwar, good evening, welcome. How are you? So these are the three things which are required to develop a heat engine. Do you understand it? So the working fluid is undergoing a thermodynamic cycle through a compressor, through a turbine, through the heat exchangers. There are four steady flow devices which are joined together one after another to make a thermodynamic cycle. That is how the heat engine is developed, or that is how heat engine is designed. I hope this is clear. If we talk about the thermal efficiency of the heat engine, what is the thermal efficiency of an engine? Because it is a work producing cyclic device. So the output upon input, this is the input supplied, this is the output. So the thermal efficiency is given by the output divided by the input. The efficiency is output upon input. So the thermal efficiency for the heat engine is equal to the net work output. Output is the net work. That is the output from the heat engine, and the input is heat supplied. We can say the thermal efficiency of the heat engine is given by W net upon QH. And from the first law of thermodynamics applied to the system, what is the first law for a thermodynamic cycle? Energy in should be equal to energy out. If we apply the first law, then we can say E in is equal to E out, isn't it? From the first law, we can say E in is equal to E out. What is the energy entering into the system? This is our system. Do you agree? QH is the heat added to the system, should be equal to W net is the work done by the system, plus QL is the heat rejected from the system. So what is W net? Can we write from the first law of thermodynamics, can we write W net as QH minus QL? QH minus QL upon QH. So the thermal efficiency of the heat engine can also be written as 1 minus QL by QH, and this is definitely less than 100%. Why? Because W net is always, according to Kelvin-Planck statement, W net is always less than QH. So the thermal efficiency of the heat engine is always less than 100%. Can you name one cyclic device, or can you name one thermodynamic cycle which is having the efficiency as 100%? Anyone of you? Anybody can name one thermodynamic cycle which is having the thermal efficiency as 100%? Anyone? Do you understand my question? Can you guys name one thermodynamic cycle which is having the efficiency as 100%? Which is having the efficiency as 100%. This expression is valid for reversible as well as irreversible cycles. Yes, no one. I was thinking somebody will write Carnot cycle. Let me tell you, no cycle can have the efficiency as 100%. The thermal efficiency is always less than 1. Whether it is a Carnot cycle, reversible cycle or irreversible cycle. The only thing is the Carnot cycle is having the maximum efficiency because it is a reversible cycle, totally reversible cycle. That is why the Carnot cycle is having the maximum efficiency, but it is not 100%. All right. Now let us talk about the second statement of second law of thermodynamics. What is that? That is the Clausius statement of second law. But before that, you must be aware, if you are not aware guys, on 6th of June, that is on Sunday at 7:30 p.m, there will be free, completely free GATE workshop taken by Dheeraj sir to make you understand how you can secure all India rank in a single or a double digit rank in GATE 2024 examination. So he will be giving you some important tips and tricks to get your preparation in the right direction to achieve the single digit or the double digit rank in your upcoming GATE examination. So it is completely free. You can register yourself to the workshop and do attend it with your full dedication, full positivity. It will definitely help you to make your preparation journey smooth and more result oriented. All right. And after the class, do not forget to go through the description box. There are important links which are there in the description box. All right. And please do like this session. It encourages us as a faculty. It is our achievement or encouragement that more and more people join, more and more students get benefit of these sessions, our job is done. So do like this session and do share this session to all your friends and colleagues who are going to appear for the GATE or ESE or any other competitive examination. Let us quickly talk about the Clausius statement of second law of thermodynamics. According to Clausius statement, as I said, the heat at higher temperature is of higher quality. Heat at higher temperature is of high quality, and the same heat at lower temperature is of low quality. That is what I told you. So the heat cannot flow, the heat always flow from high temperature to low temperature, because the energy, the process, a natural process always takes place in the direction of decreasing the quality of energy. That is what is second law all about. The energy or the process, a natural process always happens in the direction of decreasing the quality of the energy. So heat always flow from high temperature to low temperature. High temperature to low temperature. Naturally, heat always flow from high temperature to low temperature. But if we want the heat to flow from low temperature to high temperature, we need to supply some additional support. We need to do some additional work to make the heat flow from low temperature to high temperature. That is called as Clausius statement of second law of thermodynamics. So according to Clausius statement of second law of thermodynamics, we can say it is impossible, again it is impossible to construct a cyclic device which transfers the heat from lower temperature body to the higher temperature body without any external support. So we can say naturally heat flows from high temperature to low temperature without any external work. Isn't it? To make the heat to flow from low temperature body to higher temperature body, we need to do some external work. We need to do some external support. We need to provide some external support through the work. That gives the concept of refrigerator and heat pump. That gives the concept of, that gives the designing of a refrigerator and heat pump. Both are anti-clockwise cycles. Why they are anti-clockwise cycle? They consume work. They are work consuming cyclic device. So they are anti-clockwise. Both refrigeration cycle and heat pump cycles are anti-clockwise cycle. I told you the heat engine cycle is a clockwise cycle which develops some work, whereas the refrigeration and the heat pump cycles are anti-clockwise cycle because they are work consuming cycle. So let us talk about the refrigerator first. The refrigerator is the work consuming cyclic device. Again, we need source, we need a sink, we need a working fluid. That is our system which is undergoing a thermodynamic cycle. So these are the three requirements to develop a refrigerator. And what is a refrigerator? It is a work consuming cyclic device or anti-clockwise cycle which takes place in the anti-clockwise direction, which maintains lower temperature compared to the surrounding. Refrigerator is used to maintain the lower temperature compared to the outside, compared to the atmosphere, compared to the environment. So if we design a refrigerator, this is the storage space, refrigerated space, and the heat is flowing from lower temperature, TL is less than TH. The heat is flowing to the system. This is our system which is undergoing an anti-clockwise thermodynamic cycle by the help of work input. This is the required input, and the heat is flowing from lower temperature to high temperature body. This is how refrigerator is designed. There is a compressor, there is a expansion device, there are heat exchangers which are connected one after another, through which the working fluid is undergoing a thermodynamic cycle. Right? So desired output is maintaining the lower temperature. This is our desired output. Is this clear? right? This is the refrigerator. Can you let me know what is the source? Which one of them is source? Which one of them is source? Yes. Do you agree this is the source here? Source is the reservoir which supplies the heat to the system, isn't it? So many students think the higher temperature body is the source. No, the source can be the lower temperature body or can be higher temperature body. The only definition of source and the sink, the only thing which differentiates the source from the sink is the source always supply the heat to the system and the sink always gets the heat from the system. So this is the sink. Sink is the environment or ambient or the ocean or the river. Now it is to maintain the lower temperature. QL is the heat supplied to the system from the source, and work is done on the system to move the heat from the lower temperature body to the higher temperature body. QH is the heat rejected from the system. QH is the heat rejected. All right. So this is how the refrigerator is designed. We define the refrigeration effect, that is QL. Refrigeration effect is the amount of heat which need to be extracted from the storage space or the cold storage space in order to maintain the lower temperature in that. So QL is the refrigeration effect. We call QL to be the refrigeration effect, and the unit of this is, what is the unit? That is called as ton, and 1 ton of refrigeration effect is equal to 3.5 kilojoule per second or 3.5 kilowatt. 3.5 kilowatt is the 1 ton of refrigeration effect. Here we define the coefficient of performance because it is work consuming cycle. Because it is work consuming cycle, so we do not define the thermal efficiency. Thermal efficiency is always defined for the work producing cycles, whereas for work consuming cycle it is the coefficient of performance, or we can call it as energy performing ratio. It is also called as EPR. And as the COP increases, we can say the running cost or W net decreases. Running cost of the cycle decreases, or we can say the performance increases. Higher is the COP, higher will be the performance, because the running cost of the device, running cost decreases. And how do we define COP? That is the ratio of desired output to the required input. The ratio of desired output to the required input is called as COP. And COP for a refrigerator, what is the desired output? Desired output is maintaining the lower temperature, isn't it? So QL upon required input is W in. And according to first law of thermodynamics for the system, we can again say, according to first law of thermodynamics, we can again say that, what we can say, according to first law of thermodynamics, we can say QL plus W should be equal to, QL plus W should be equal to QH. So from here, W can be written as QL upon QH minus QL. Do you understand what is the COP for a refrigerator? It is less than 1 or greater than 1. For a refrigerator, will the COP be greater than 1 or less than 1? Anybody? Can anybody comment about this? COP for a refrigerator, will it be greater than 1 or less than 1? COP for a refrigerator. It can either be less than 1 or it can be greater than 1. COP for a refrigerator, because QL can be less than or can be greater than W. QL can be less than W, it can be greater than W, but QH is always greater than W. QH is always greater than W. QH is always greater than W, but QL can be less than W, can be greater than W, right? It can be anything. So we are going to start one more information before proceeding for the heat pump. We are going to start important series for discussing the last 5-year GATE questions. It is going to be very important for all the GATE aspirants, because every examination is having some pattern and you need to understand that pattern of that particular examination to excel in that examination. So the only way to understand the pattern is by going through the previous year question papers. So we are coming up with the previous year question papers to discuss for each and every subject starting from 5th of June. All right. And lastly, let us talk about the heat pump. It is again the work consuming cyclic device which maintains the higher temperature compared to the surrounding. Heat pump is to maintain the higher temperature compared to the surrounding. So this is again the sink which is at higher temperature. This is our desired output, or this is desired output. This is the QH will be the desired output, and required input is this Q in. The signs are incorrect. Required input is Q in. This is our source which supply the energy. So again the COP for a heat pump is what is the desired output. It is to maintain the higher temperature. QH upon required input is W, or we can say QH upon QH minus QL. These expressions are valid for reversible as well as irreversible cycles. These expressions are valid for reversible as well as irreversible cycles. Don't think that these expressions are valid only for reversible or only for irreversible. Are you getting it? So as I said, QH is always greater than W. So COP for the heat pump is always greater than 1. Do you understand it? For a heat pump, COP is always greater than 1. Right? COP for heat pump is always greater than 1. I have already told you about the COP for the heat pump, which is greater than 1. So if we generalize, if we talk about for same QH and QL, if QH and QL are same, then we can say COP for a heat pump is equal to QH upon QH minus QL, isn't it? And COP for a refrigerator is QL upon QH minus QL. So if we subtract these two, COP for the heat pump minus COP for the refrigerator, you will get it as 1. Or we can say COP for the heat pump is equal to 1 plus COP for a refrigerator, and that is why COP for the heat pump is greater than 1. But if we talk about the thermal efficiency, what is if the cyclic device is an engine, so what is the thermal efficiency of the heat engine? Can we say W upon QH? So W upon QH, or we can say QH minus QL upon QH. If you see these two, then it is COP for the heat pump is the reciprocal of thermal efficiency, isn't it? It is 1 upon thermal efficiency of the heat engine. This is the relation between these three cyclic devices. COP for the heat pump is 1 plus COP for a refrigerator working between the same input and output conditions, and that is equal to 1 upon thermal efficiency of the heat engine, which is having the same input and output. So we can comfortably say a refrigerator and the heat pump are nothing but reversed heat engine cycles, because heat engine cycles are work producing, whereas heat consuming cycles are refrigerator and heat pump are work consuming cycle. This is your homework. Please give it a try at home. Try to find it the answer, and do share your answer in the comment section of this session. All right. So tomorrow at 11 a.m. I will be meeting again, and we will talk about numericals practice for the basic thermodynamics. So do join me this session tomorrow at 11, and do revise a little bit before coming to the session. It will be fun. It will be interesting. It will be joyful to understand the application part of these concepts which we have discussed so far. All right. And on Saturdays, we are having two beautiful series. One is Knowing the Legends and another is the Raftar series. You can enjoy the concept or enjoy the technology through these interesting sessions as well. All right. This is my mail ID to join, to discuss any doubt, and you can join me on the Telegram also, that is Mechanical by Chandrasekhar. So guys, that is all from my side for the session. I hope you enjoyed it. Please do like and share this session to all your friends and colleagues, and do solve the numerical given for assignment. I will see you tomorrow at 11. Till then, enjoy, take care, have a good day, and have a great future ahead. Thank you guys. Thank you very much for joining in. Jai Hind.